Welcome to our Regression for Research Series Part 2, Ordinary Least Squares Model or OLS. If you can recall from our last video, we said that an OLS model uses a continuous dependent variable and a continuous independent variable. We also said that it is the most common and most widely used model out there. Before proceeding with the actual model, we must first assure that our subjects or observations are randomly selected and independent of each other. Again, randomly selected, independent. Now we can go to our example of understanding the effect of calorie intake and exercise duration on average weight loss in kilograms. We can represent this with the simple equation weight loss equals calories plus hours. From here, we can define our dependent variable and two independent variables. Average weight loss in kilograms being the dependent, and calorie intake in calories and exercise duration in hours as our independent variables. Now let's try to relate this to the basic form of the OLS model equation. Y here is the dependent variable, and x1 and x2 are the independent variables respectively. Okay, so we already know where our variables are. Let's discuss the remaining parts of the equation. Beta null is the constant term, similar to the y-intercept of a simple linear equation. Beta 1 and beta 2 are the coefficients or effects of IV1 and IV2 respectively. Epsilon here is what we call the error term, or how far the fitted equation is from the actual data point. Let's go back to our example and our simple equation. Suppose the data for 15 individuals is listed as follows. Performing an OLS regression will have results looking like this. I know it seems complicated, but let's try to understand what it means and what we need to look at. We basically need to look at 5 basic components: the overall ANOVA p-value, adjusted r-square, the results regarding our IVs, and within that, the individual p-values and effects. First, the overall ANOVA p-value will tell us if the model is significant or not. Like any other p-values, if its value is less than our level of significance, say 0.05, then we can say that the model is significant. Here, it has a value of approximately 0.006, so we have a significant model. Next, let's talk about the adjusted r-square. We're not going to explain how it was computed, but we'll just say how to read it. The adjusted r-square is an overall measure of how good the independent variables explain the dependent variable. It answers the question what percentage of the variation of the dependent variable is explained by the variation of the independent variables. A note to remember is that the higher the r-square, the better. A good model has a recommended r-square value of 60% or higher. From our results earlier, around 50.39% of the variability of average weight loss in kilograms can be explained by the variability of calorie intake and exercise duration. The value here is low since we only have 15 observations. Now we have the individual variable effects and p-values. Similarly, the p-values are used to determine which variables are significant in the model, and to read it is just similar to how we read other p-values. If the p-value of an independent variable is lower than the level of significance, then that variable is significant. Here, only calorie intake seems to be significant with a p-value of 0.00627. Next, we look at the estimate of this variable and interpret it as its effect to our dependent variable. So, a unit increase in calorie intake yields to 0.06757 increase in average weight loss in kilograms, holding all other variables constant. Lastly, we have the model assumptions. Since regression is a complicated procedure, it has a strict set of assumptions that need to be satisfied to be considered valid. Although we'll not go through them in detail, we'll just list them here for awareness. First, you need to familiarize yourself with the concept of residuals. Then, there comes the assumption of independence of residuals, normality of residuals, homoscedasticity, and autocorrelation. In addition, there are things you need to watch out for like multicollinearity and the presence of possible outliers. Some diagnostics or tests you can use to check or correct these are by using residual plots, the Anderson-Darling test, Bruce-Pagan test, Durbin-Watson test, variance inflation factor, Cook's D, DF-fits, and DF-betas. All these seem very complicated, so if you don't have a background in statistics, it's best to consult a statistician to make sure you're doing the right thing and that your model is valid. Now, assuming all assumptions are satisfied, We can now have our final model to look something like this. Estimated average weight loss in kilograms is now expressed as a function of calorie intake. Hope you have a better grasp of OLS models and learned something new today. Subscribe for more and comment down below what other topics you want us to cover. Got questions? Want to learn more about statistics? Need help on your thesis? We got you. Just visit our Facebook page or contact us through the following.